Okay, so 270 kilogram rocket, 185 kilograms of which is fuel, burns all of its fuel in 26 seconds with an exhaust velocity of 852 meters per second. What are its initial and final accelerations as it takes off from Earth? Okay, so again, let's figure out what the initial and final masses are. Okay, so the initial mass is going to be 270 kilograms, right? And then that final mass is going to be 270 minus 185. So let's figure that out. That's higher math. I can't do that. Minus 185. That is 85 kilograms, eh? This is a well-designed rocket, right? Most of its mass is the fuel, okay? Okay. Let's figure out the thrust of the engine, too. I feel like we should do that. Okay. There we go. Okay, so force times time is mass delta V, so force times, and it takes 26 seconds to burn the fuel, right? So 26 seconds. It burns 185 kilograms of fuel. Okay, so just be careful, right? Don't use the mass of the rocket. Don't burn the whole rocket. Everybody wants to don't burn the whole rocket. Just burn the fuel, okay? And then our delta V is 852. All right, let's figure this out. What's the thrust of this engine? And that's going to be 185 times 852 divided by 26, but in 6062. So the force equals 6062.3 newtons. Ta-da! Okay. And now we're set. Now we've figured out the initial and final mass, right? Okay, we figured out the thrust of the engine. Now we can solve our F equals ma, right? So here's our rocket. We've got 6062.3 newtons up. The force of gravity is going to be, what's the mass? The mass is 270. So 270 times 9.81. That's 2648.7. Right? So that's 2648.7 newtons. And now I'm set. Now I can figure this out. So 6062.3 minus 2648.7 is 270 times A. Okay, so that guy minus this guy divided by 270. I'm getting 12.6 meters per second squared. Okay. All right, so now let's do the other one. The next one is, it's got a mass of 85 kilograms, but the same thrust, right? Okay, so rocket, we've got, still have 6062.3 newtons up, right? The force down is, what is that? The force of gravity is 85 times 9.81. So 85 times 9.81 is 833.85. All right, and now we're set. Now we can go 6062.3 minus 833.5 equals 85 times A. Okay, so let's do this. All right, where is it? There it is. No, there it is. I got it. All right, I'm just hitting the up arrow minus this guy. So I got like 5228 now. And then I'm going to divide by 85. I get 61.5 meters per second squared. Right? So again, find the initial and final masses, find the thrust. Be careful that you just use the mass of the fuel, right? Yeah, this is what everybody does. They use like the whole rocket. Can't burn the whole rocket. There's parts that don't burn, just the fuel burns, right? So this has to be fuel. This has to be the time it takes to burn the fuel, okay?